Okay, so the next video is going to be a skill-based video. So we've talked previously about how to do different operations with polynomials. We know how to add and subtract them, which is just combining like terms. We also know how to multiply them, things like FOIL, distributive property, things like that. And now what we're going to talk about is, well, what if you're asked to do division with polynomials? What does that look like? So the first method that we're going to talk about is called long division. And long division is an algorithm. It's a process that you learned in probably about third grade. And it looked something like this. Divide 2,382 divided by 6. And so you asked yourself questions like 6 goes into 2, it doesn't. 6 goes into 23, it does. It goes in 3 times. And you multiplied 6 and 3. What you always did was then subtract. So this subtraction gives you 5. Drop the next number. 6 goes into 58 9 times. 9 times 6 is going to give you 54. And again, you subtract. You subtract, you get 4. You drop the next number, which is a 2. 6 goes into 42 7 times, and you multiply. When you multiply and subtract, you get a remainder of 0. So what that means is 6 went into this number exactly 397 times. If you ever have a number here after your division is done, your remainder always goes as a fraction over what you're dividing by. So just for argument's sake, say that this had been a 3 instead, and that this had been a 43, then my remainder would have been 1, and my final answer would have been 397 and 1/6. So what we're going to do is use that same algorithm, but we're going to do it with polynomials. So the first thing we're going to do is set up the problem exactly the same way. So we're going to first put the polynomial in the house. So 3x to the fourth, 5x cubed, plus 4x minus 6. And we're dividing by this, x squared minus 3x and plus 5. So what we're going to do is do step by step. First thing you're going to ask yourself, x squared goes into 3x to the fourth how many times? So in other words, what times x squared gives you 3x to the fourth? The answer to that is 3x squared. When you multiply, you're now going to multiply that term by all 3 of these. So you're going to get 3x to the fourth, you're going to get a minus 9x cubed, and you're going to get a plus 15x squared. And all you're going to do now is subtract. Now remembering when you subtract things, all it's doing is changing all of the signs. So we're going to change all of those signs and make sure we subtract. So this column goes away. The second column, when you subtract those, you end up with a 4x cubed. You can't subtract these two. This is an x, that's an x squared. You can't subtract those. So the 15x squared comes down, and we bring down the next term, which is a 4x. Now we go through the whole process again. X squared goes into 4x cubed how many times? So what times x squared gives you 4x cubed? The answer to that is 4x. And you're going to distribute and multiply. 4x times all 3. You get a 4x cubed, you get a minus 12x squared, and you get a plus 20x. Again, you're going to change all of the signs so that you can just add straight down. So we would have a minus, a plus, and a minus. And let's see what that gives us. First column goes away. Second column, I get a negative 3x squared. Last column, you get a negative 16x. And we've got this 6 we still need to bring down. Now we go through the same process one more time. X squared goes into negative 3x squared, negative 3 times. And we're going to distribute. Negative 3 multiplied by all 3 of these. So a negative 3x squared, a plus 9x, and a minus 15. Once again, we're going to change all of the signs. And we're just going to add the columns. First column goes away. Second column, I get a negative 25x. Last column, that gives me a plus 9. X squared no longer goes into this, so this is known as your remainder. So what do I do with that remainder? It gets written as a fraction over my divisor. So my answer, 3x squared plus 4x minus 3 plus remainder over divisor. Negative 25x plus 9 over x squared minus 3x plus 5. And that's what your end answer would look like. Now this one is a little more complicated because we started with a quartic polynomial and we divided by a quadratic polynomial. So the higher the degree, a little bit more tedious the problem is. This next problem isn't so bad because we've got a cubic and a linear. So the process is actually going to be a little simpler in this next one. So let's first draw the house, put my polynomial inside. And now we're going to follow the same process we did in the last problem. X goes into x cubed how many times? You'd have to multiply by x squared, and you distribute. So we get x cubed minus 2x squared. Again, we're going to change both signs, and we're going to add our columns. First one cancels. Second one, we end up with a 7x squared. We bring down the next term, 7x. Now we ask ourselves the question, x into 7x squared, it goes in 7x times, and you distribute. 7x squared minus 14x. Again, we're going to change the signs and add the columns. Cancels, and you get a 7x. Bring down the plus 2. Last time, x goes into 7x 7 times, and we multiply. 7x minus 14, and we're going to change both signs so that we can add the columns. 7x's cancel. That column gives me a 16. That is my remainder. So how do I write my final answer? I take my answer on the top, x squared plus 7x plus 7, and I add on my remainder over my divisor written as a fraction. So that's what my final answer would look like. Now, this process is a long process and it's a little tedious. So what we learn is that this is not the only way we can divide. There's this other method called synthetic division. And so what we learn is we can use synthetic division, which is the easier process, anytime what I'm dividing by is linear. So things like x plus 3, x minus 3, x plus 1, 3x minus 4, anytime this is linear, you can use this synthetic division process in order to divide. So what does the process look like? I'm going to take this polynomial, and the first thing it's going to say is write the coefficients in order of descending exponents, and write the values of k on to the left. So the first thing is these numbers all get written. Something to pay attention to, reason why there's a 0 in the middle. Look at the order of the exponents. We have a fourth power, a third power, a first power, and a 0 power. The second power is missing in the middle, so that term has to get filled in with a 0. That's really, really important. Anytime there's a term missing, you have to fill that spot with a 0. Once I have those written, we're going to put a little box. And on the outside out here, I'm going to take the 0 of that. So the 0 of the divisor. So since this says x minus 3, I'm going to put a positive 3 out there. If this had said x plus 3, I would use a negative 3 out here. It's always the 0 of that parenthesis. So what does the process look like? The first thing you're going to do, drop the first number. So that 2 goes down. Now all it is multiplication and addition. 3 times 2 is 6. Add the column, you get 1. 3 times 1 is 3. Add the column, you get 3. 3 times 3 is 9. Add the column, you get 5. 3 times 5 is 15. Add the column, you get 23. This number on the end is your remainder. So what do I do with all of these numbers? What do they represent? This is your polynomial with your degree reduced by 1. So if we started with a fourth power, that means that this first term is the x cubed, x squared, x number on the end, and this is what gets written as a fraction because it's your remainder. So the first term, the 2x, would be 2x cubed, then x squared, then a 3x, then a plus 5. This gets written as a fraction over my original divisor. So it's going to go over that parenthesis of x minus 3. And this process is called synthetic division. So what we could have done with this problem we did here, so we did this problem using long division. We could have actually done it using synthetic division and gotten the same answer. So I'm going to show you that this actually would come out the same. So doing this problem by synthetic division, again, we already did it by long division, but let's do it by synthetic so I can show you that the answer comes out the same. First thing, draw your house and list all your numbers. So 1, 5, -7, and 2. You're dividing by x minus 2, so you use its 0. So I'm going to use positive 2. And then you do the process. The process is drop the first number and multiply. 2 times 1 is 2. Add, you get 7. 2 times 7 is 14. Add, you get 7. 2 times 7 is 14. Add, you get 16. That's my remainder. And if you look at the answer we got doing it the long way, we got x squared plus 7x plus 7, 16 over x minus 2. Same thing here. That's my x squared. There's my 7x. There's my 7. And the 16 over x minus 2. So the same answer. Now, will this always happen? Yes, as long as the divisor is linear. If this was x squared minus 2, you can't use synthetic division. You have to do long division. The only time this process works is if this divisor is linear. So, let's talk about doing a couple problems as practice. And then we'll talk about why on earth we even care about this process. So this first problem, we'll just do one more example. We do this problem. The first thing you're going to do is list all your numbers. Again, make sure that you notice if any of the terms are missing. So cube, square, x, and nothing. So we're good. 2, 1, -8, and 5. This says x plus 3, which means that I'm going to use -3 outside the box. And we're going to drop and multiply. So we drop the 2, multiply, we get -6. Add, we get -5. Multiply, we get positive 15. Add, we get a positive 7. Multiply, we get -21. And add, we get -16. That number on the end being my remainder. And all I'm doing is I started with a cubic, so this is now a quadratic. So I would say a 2x squared minus 5x plus 7 minus 16 over x plus 3. And that's the process called synthetic division. Now, sometimes you'll hear synthetic division actually called synthetic substitution. So let's talk about why sometimes you'll hear it called that. Synthetic substitution. There's this theorem called remainder theorem. And what it says is, if you take this polynomial and you do synthetic division with that number, you're going to get the exact same answer as the remainder as you would get if you just plugged -2 in the equation. Okay, so let me do a little bit of an illustration on what that means. So let's just do straight evaluation. I'm going to take -2 and plug it in for all of the x's. So if I did that, f of -2, we'd have 3 times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7. So let's find out. If I just plug in an x value of -2, What do I get as the answer? So I'm going to go to my calculator and let's find out. Negative 2 cubed plus 8 times negative 2 squared. Oops, I didn't bring that out of the exponent. Okay, plus 8 times negative 2 squared plus 5 times negative 2 minus 7. Okay, so I get an answer of negative 9. So when I plug in negative 2, I got an answer of negative 9. This theorem says if you do synthetic division using the exact same values, you're going to get negative 9 as the remainder. So let's find out if that's true. Listing the numbers, 3, 8, 5, and negative 7. X equals negative 2 is the 0. So that's what we're going to use. And let's find out if my remainder comes out the same as my evaluation. And if I did this correctly, it should come out the same. Drop the 3 and multiply. You get negative 6. Add, you get 2. Multiply, you get negative 4. Add, you get 1. Multiply, you get negative 2. Add, you get negative 9. And notice that my remainder here is the exact same thing as I got when I evaluated using negative 9. That's called remainder theorem. So let's talk about why remainder theorem is important and what we can do about it. So some of you might be thinking, and the question I'm hoping, well, what if that number on the end, what if it's a number like 0? What does that mean? What that means is what the last part of the lesson and video are about. It's this thing called factor theorem. So if you take and do synthetic division, and this gives you a remainder of 0 when you divide, that means that x plus 2 is a factor of the original equation. So let's talk about and see what does that mean and what can I do with that then. So if I do synthetic division, none of my terms are missing, so I'm going to list them all right in order. Since it's x plus 2, I'm going to use the 0, which is negative 2, and we're going to do the process. Drop the 3 and multiply. You get negative 6. Add, you get negative 10. Multiply, you get positive 20. Add, you get negative 8. Multiply, you get positive 16. And when you add those, you get a remainder of 0. That means that x plus 2 is a factor, and it means that negative 2 is a 0. So this function would hit the x-axis at negative 2. Now, why is this important and how does this help? Well, this now went from a cubic, this is now a quadratic. That's 3x squared minus 10x minus 8. So if I want to factor the rest of this, this now is pretty easy to factor because it's now a quadratic. So we can use our methods to figure out, well, what are the rest of the factors? And then in turn, what are the rest of the zeros? So I'm going to take this and I'm going to factor it using AC factoring. Just as a quick little review, what does it look like? Take the 3 and multiply. X squared minus 10x minus 24. So I'm looking for factors of 24 that are going to add to give me negative 10. Those factors are going to be x minus 12 and x plus 2. Now here's the part where a lot of you mess up your process of AC factoring. I multiplied by that 3, so I have to plug it back in still. That's why I left spaces in front of both of these. And then your job was to then take it out of whichever one it comes out of nicely. So it comes out of this first one nicely. Take that 3 out, and you're left with an x minus 4. The other one, it doesn't come out nicely, so there are your remaining factors. So this polynomial factored completely would be the one they gave me, x plus 2, and then the 2 I found, x minus 4 and 3x plus 2. That's how you can use synthetic division to do a problem. You can use synthetic division if you get a remainder of 0. That means that what you used is indeed a factor, and you can finish factoring out the rest because you have a quadratic. So let's do one more like that. So let's use this one. It says factor completely knowing that x minus 4 is a factor. So let's do this one. So I'm going to turn upside down 1, negative 22, and 40. X minus 4 is the factor, so I want to use it 0. Drop the 1 and multiply. Okay, so look at the process I just did, kind of digest it mathematically. Drop the 1, multiplied got 4, added got 3. Multiply got 12, added got negative 10. Multiply got negative 40, added got 0. So that means that what's left over here is a quadratic because we started at a cubic. So that's x squared plus 3x minus 10. And so we need to factor this. Factors of negative 10 that are going to add to positive 3. Those factors are just x plus 5 and x minus 2. And so if I want to write this as factored completely, I need to include that x minus 4. And there's my end answer. So not only can I use this to factor completely, I can also use it to then find zeros. So where does the graph hit the x-axis? So let's do a problem like this one. Okay, notice it says find the zeros given that f of negative 2 is 0. So that's telling you that x plus 2 is a factor. It's also telling you that negative 2 is a 0. So there are 3 ways that they could give you the number that you're going to use in synthetic division. This would be one way, showing you that f of negative 2 is 0, telling you that x plus 2 is a factor, or they could just flat out say negative 2 is a 0. So those are the 3 ways that you're going to be told what number to use in synthetic. So we're going to do one more problem and then we're going to be done. So I'm actually going to do this one here. First thing, let's set up the synthetic. No terms missing. So 1, 8, 5, and negative 14. Since f of negative 2 equals 0, that means that negative 2 is a 0. So that is the number I'm going to use. And I'm going to drop and multiply. So this proves that negative 2 is a 0 because I got a remainder of 0. So again, kind of digest that mathematically. Drop the 1 and multiply. Add. Multiply. Add. Multiply. So this here is now a quadratic because our degree goes down by 1. So that is an x squared plus 6x minus 7. And we're going to do equals 0 because we want to find the other zeros. This isn't just asking me to factor, it's asking me to find the zeros now. Factoring this is easy. It's x plus 7 and x minus 1, which means that my remaining zeros are 1 and negative 7. Last thing that I'll ask you to do, if they give you a 0, still please list it with the other ones so that I was supposed to find 3, and we actually did find 3. They gave me 1, I found 2 more. So what do I want you to do then before you come to class next class? I would really like you to copy this problem here and do this on your own, please. So go ahead and pause the video and copy that one. I would also like you to do this one here. So again, go ahead and copy that, pause the video and copy it. And I would like you to do this one. Okay, again, they gave you the fact that x minus 4 is a factor, so let me recopy this because it's kind of wrote over the top of it. But that's f of x equals x cubed minus 6x squared plus 5x and a plus 12. And you're told that x minus 4 is a factor. So that gives you 3 problems that I'd like you to try before class, next class, and then we will discuss any issues that you have with it.